Hello students, A2 Chemistry, chapter is Chemical Energetics, lecture number 1. Today in this lecture we are going to study some basic definitions that you people have studied in AS. We are going to study those definitions since these definitions can be asked again in your A2 exams. Now to write down definitions, there are 3 important steps that you must remember. Out of these 3 steps, 2 steps, they are common for all the definitions that we write down in chemical energetics. For example, the first step that you are supposed to write down for each and every definition in chemical energetics, it is the enthalpy change. This point, if it is mentioned in the definition, you will score 1 mark. Second point, it is variable, and again the third point, it is constant, where you will have to write down under standard conditions. So whenever you are going to write down any definition in chemical energetics, out of the 3 parts, out of the 3 steps, 2 steps simply you can memorize quite easily. Only the second piece of information you will have to modify according to the specific type of enthalpy change. Now how is that? Let's have a look. Before that, students, if you have not subscribed my channel yet, I invite you people to subscribe my channel and also push the bell icon. Thank you. Okay, let's start with today's lecture. First definition that we studied in AS, we are going to revise. Now it is standard enthalpy change of formation. The symbol is delta H F naught. Now, what you should remember whenever you are asked in your exams, what do you mean by standard enthalpy change of formation? To score maximum marks, you can mention 3 steps in the definition. Number 1, the enthalpy change. Number 2, when 1 mole of a compound is formed from its elements. And number 3, under standard conditions. So this is a complete definition. Whenever you want to tell what do you mean by standard enthalpy change of formation, sometimes along with this definition it is also a requirement of the paper setter that you must give an example in the form of a chemical equation. So one chemical equation that we can write down for to explain, to elaborate standard enthalpy change of formation, it is, if we write down an equation for the formation of potassium manganate 7 KMnO4, it is very simple to write down an equation for the formation of KMnO4. You just look at the compound potassium manganate 7. It is made up of 3 elements: potassium, K, it is a solid; manganese, Mn, it is solid; and oxygen, O2, gas. And you will balance the equation in such a way that there must be 1 mole of KMnO4 on the right hand side. So to balance oxygen, we will have to insert a coefficient of 2 before oxygen on the left hand side. So this way you can write down a balanced equation for the formation of KMnO4 solid. Okay, this is the first definition that we studied in AS, and we revised it in our A2 syllabus. Second definition that we studied, we must revise, can be asked again in your A2 syllabus. It is standard enthalpy change of combustion. Again, 3 steps. The enthalpy change, when 1 mole of a substance is burnt in the presence of excess air or oxygen under standard conditions. Excess air or oxygen is made available to ensure that the compound must burn completely, and all the elements involved in a given compound, they must become able to produce their stable oxide. For example, if you have been given methane, you know methane is made up of carbon and hydrogen. Carbon will combine with oxygen to produce carbon dioxide, that is the stable oxide of carbon, and hydrogen and oxygen will combine to produce water, the stable oxide of hydrogen. So this way, in this case, you can see you have burnt 1 mole of methane and you have balanced the rest of the equation accordingly. Simply you will have to keep in your mind that you can take you can use 1 mole of methane, the substance that you are going to burn. The third definition that you must revise, it is standard enthalpy change of neutralization. Standard enthalpy change of neutralization is the enthalpy change when 1 mole of water is produced by the combination of an acid with an alkali under standard conditions. Now, what you know, whenever an acid reacts with an alkaline solution, an acid it gives away H ion, while an alkali it gives away OH, and H combines when it combines with OH ion, neutralization takes place and water is the product. So simply you can remember neutralization is a reaction in which H and OH ion they combine to produce water. Likewise, the next definition you must know, it is standard enthalpy change of atomization, delta H AT. Now standard enthalpy change of atomization can also be defined like this: the enthalpy change when 1 mole of gaseous atom is produced under standard conditions. The enthalpy change when 1 mole of gaseous atom is formed from its elements under standard conditions. What does this mean? What is atomization? Simply you should remember, whenever you want to atomize some element, you must write down the symbol of that element along with its state symbol gas at the base of that symbol. This is atomization. For example, if you have been given hydrogen and you are asked to atomize hydrogen, you know hydrogen is diatomic. You will take half mole of hydrogen to produce 1 mole of gaseous hydrogen atom. Look at the product side, you can see there is 1 mole of hydrogen atom and it is in the gaseous state. So atomization mean we must have an element in atomic form and the state must be gas. So this is atomization. Okay, next definition that we studied in AS chemistry, it is standard enthalpy change of solution. How you can define it: the enthalpy change when 1 mole of a substance, 1 mole of a solute is dissolved in a solvent to form an infinitely dilute solution. Now, what you must remember, most common solvent that we use in chemistry, it is water, and water is known as universal solvent. After water, which solvent we use commonly? It is ethanol. Second thing you can see in the definition, we have used the term infinitely dilute solution. What does this mean? It means that the solvent must be provided in excess so that all the energy that can be released or absorbed, the whole enthalpy change should take place in a single go simultaneously. How you can represent this enthalpy change? Simply take NaOH. NaOH is a solid. If you add it in water as a solvent, it is written and spoken as aqua. When you will add NaOH in water, NaOH solid will dissolve in water and it will become hydrated. Hydrated NaOH will be known as solution of NaOH. Hydrated mean that the ions they have become aqueous. Another definition that we studied in AS, it is standard enthalpy change of hydration. Again, you can write it down quite easily. You can say it is the enthalpy change when 1 mole of gaseous ions uh, are hydrated by water molecules under standard conditions. What does hydrated mean? Hydrated means surrounded and attracted by water molecules. For example, if you have been given 1 mole of sodium gaseous ion, when you will add them in water molecules they will surround sodium ions in such a way that the negative part of water, that is oxygen they will surround sodium because oppositely charged and they attract each other. So this surrounding and attraction of positive ion by the negative end of water, it is known as hydration. Okay students, these are the most common definitions we studied in AS. These definitions are important again your A2 syllabus, because in A2 we will discuss Born-Haber cycle, the only topic under the heading of chemical energetics in detail. And for studying Born-Haber cycle, these definitions they are helpful. Okay, besides these definitions, some more definition that you must know for studying Born-Haber cycle. The next one again you people have studied in AS under the heading of atomic structure. It is ionization energy. So again we are going to have a quick revision. What is ionization energy? As you people know very well, ionization energy is the enthalpy change that is related to the process of oxidation, to the process of loss of electron. So, what is ionization energy? It is the enthalpy change for oxidation, for the loss of electron. And remember, ionization energy is always endothermic. Why it is always endothermic? Why always energy is absorbed? Because whenever we remove an electron, we have to break a bond. Which bond, which force is broken when we remove an electron? That force is known as electrostatic force of attraction. The force of attraction between nucleus, between proton and electron. That electrostatic force is broken. That is why energy must be absorbed. And that absorbed energy is known as ionization energy. Then you must remember uh, an element, it can lose a number of electrons. For example, if an element loses first electron only, this type of ionization energy can be known as first ionization energy, denoted as delta H IE1. In this case, you can see the change in oxidation state, the change in charge of X from 0 to 1 positive. So X has become unipositive ion. Whenever it happens like this type of ionization energy is known as first ionization energy. And then if you remove one more mole of electron from X, from X1 positive, it may become X2 positive, unipositive ion. When it becomes dipositive ion, this type of ionization energy is known as second ionization energy, delta H IE2. And likewise for third ionization energy, you can notice a change from dipositive ion, it would become tripositive ion. This is third ionization energy. So this is one thing, you must know ionization energy equations, how they are written. Always electrons are removed, and mostly whenever electrons are removed, they are written on the right hand side of the equation. Second thing, whenever electrons are removed, we get positively charged ions, unipositive, dipositive and tripositive ion. Now, how to define these three types of ionization energy? Again, it is very simple. You can memorize, you can learn a general format, how to write down definition for the first, second and third ionization energy. Whenever you want to define first, second and third ionization energy, the first step that you can mention in your definition, it is the enthalpy change when one mole of electron is removed. Now these two steps, they are common. You can write down, you will have to write down in all the three definitions, whether it is first, second or third. The first step is the enthalpy change, the second step is when one mole of electron is removed, and the third step, it is variable. You will have to modify the third step only depending on the type of ionization energy. Like I'm going to tell you the complete definition for the first ionization energy, and then you can write down yourself second and third ionization energy definition. Okay, what is, how you can define what is first ionization energy? Just look at the chemical equation that we have written, and you can say the enthalpy change when one mole of electron is removed from one mole of gaseous atom to produce one mole of gaseous unipositive ion, it is known as first ionization energy. The enthalpy change when one mole of electron is removed from one mole of gaseous atom to produce one mole of gaseous unipositive ion. Now students, just give it a try. Write down yourself the definition for the second and third ionization energy. You can pause the video here, and you can just try it out to write down the definition for second and third ionization energy. But remember, for second and third ionization energy, you will use the term dipositive and tripositive. Okay, students, I hope you would have tried to write down the definition for the second and third ionization energy. Just check it out. For the second ionization energy, you are supposed to write down the enthalpy change when 1 mole of electron is removed from 1 mole of gaseous unipositive ion to produce 1 mole of gaseous dipositive ion. And likewise, the third ionization energy is the enthalpy change when 1 mole of electron is removed from 1 mole of gaseous dipositive ion to 1 mole of gas to produce 1 mole of gaseous tripositive ion. Okay, I hope you people have written correct these definitions correctly. Let's move on. Okay, students, now we are going to learn a new definition, although you are familiar with the name of this type of enthalpy change. This is an enthalpy change that we will also use in the Born-Haber cycle. So let's talk about electron affinity. Now, to keep it simple in your mind, just remember ionization energy is the energy related to the process of oxidation, and electron affinity is the enthalpy change for the process of reduction. That's it. So, electron affinity is the enthalpy change when an atom undergoes reduction or when an atom gains electron. So, likewise, you can write down equations for electron affinity. For example, if X is an atom, X is an element, it will gain electron, and in this case you can see after gaining electron the X atom will become uni-negative ion. Negatively charged ions are produced during gain of electron or reduction. Okay, what this type of electron affinity is known as? This type of electron affinity is known as first electron affinity, and the symbol that we use for this, it is delta HEA1. If you want to remove one more electron, X uninegatively charged ion, it will gain one more mole of electron and it will become X dinegatively charged ion. This is second electron affinity. And likewise, third electron affinity, when dinegative ion, it becomes trinegative ion. It is delta H EA3. So it is very simple, students. You can, if you know how to write down chemical equations for ionization energy, likewise you can write down chemical equations for first, second and third electron affinity. Now for the definition, as far as definition is concerned, even that is quite obvious. There are three steps for writing the definition for the first, second and third electron affinity. What is the only change? You will start your definition for each one of these three electron affinities with the enthalpy change when one mole of electron is added. Now instead of removed, you will use the word added. That's it. And you can complete the definition like this. Okay, I'm going to tell you the definition for the first electron affinity. It would be the enthalpy change when one mole of electron is added to one mole of gaseous atom to produce one mole of gaseous uni-negative ion. Now likewise, students, you can write down yourself definition for the second and third electron affinity. Please do write. Just pause the video. Okay, if you have written, student, you can check it out. The definition for the second electron affinity would be the enthalpy change when one mole of electron is added to one mole of gaseous uninegative ion to produce one mole of gaseous dinegative ion. And the third electron affinity, the enthalpy change when one mole of electron is added to one mole of gaseous dinegative ion to produce one mole of gaseous trinegative ion. Okay, students, after definition, what information you must remember about electron affinity? You must know the nature of electron affinity. As I told you, ionization energy is always endothermic. Why it is always endothermic? Because bond is broken. Electron affinity, it has two different types of nature. Electron affinity can be exothermic as well as endothermic. For example, if you look at the first electron affinity for every element, it is always exothermic. While compared to first electron affinity, all other electron affinities, they are positive, they are endothermic. So what is the reason behind that? Let's look at the reason, simple reason that you can remember. whenever an ion it gains electron, during the addition of electron, two forces are operated. One type of force is the force of attraction. This is the force of attraction between the incoming electron and the nucleus of atom. And there is also another force, that is the force of repulsion. The force of repulsion between the incoming electron and the electrons that are already present in the valence shell of that atom. So what does this mean? There are two forces: force of attraction, force of repulsion. Force of attraction releases energy, force of repulsion absorbs energy. In the first electron affinity, in this case, force of attraction is greater than the force of repulsion. So due to that, energy released is greater than the energy absorbed. So overall, delta H, enthalpy change, it becomes negative, it becomes exothermic. Simple. But when we move on to second electron affinity, what you can see, electron is being added to a uninegatively charged ion. So what happens? Similarly charged particles, they repel each other strongly. So in this second electron affinity, the force of repulsion, it dominates the force of attraction. When the force of repulsion dominates, energy absorbed, it becomes greater than the energy released, and overall the process, it becomes endothermic. Likewise, when you move on to the third electron affinity, what you can see, the magnitude of negative charge, it has increased. Greater negative charge will cause greater inter-electronic repulsion, and the enthalpy change, it would become more endothermic. So maximum force of repulsion you can expect in the third electron affinity, and force of attraction would become minimum. So that is why simply you can remember why all electron affinities are endothermic except first electron affinity, because force of repulsion due to interelectronic repulsion, it dominates force of attraction, and force of repulsion can be overcome by absorbing energy. Okay, let's assume if we take the example of some numerical values, what you should remember, if we just look at the first electron affinity of an element, if it is negative 20 kilojoule per mole, then what will be the numerical value for second electron affinity for that element? It would not only be positive, but it would also be greater in magnitude, like it would be positive 30 kilojoule per mole. And likewise, for the third electron affinity, it would be even more positive, greater repulsion due to greater negatively charged ion. Magnitude, it will further increase. So what is the important information that I want to tell you people to be remembered for your A levels exams while solving numerical problems? You must always remember, if first electron affinity of an element is ever given, first electron affinity alone, it is always exothermic. Compared to first electron affinity, if ever you have been given two different electron affinities of an element, first and second, remember the sum of first and second electron affinity, it will always be endothermic. And likewise, if ever an element has three electron affinities, the sum of first, second, and third electron affinity, it is also always endothermic. I hope you would have enjoyed this lecture. Thank you. Bye for now.